Bonjour, hello. Um, my name is Spencer Gibb. I know you have lots of choices here at Devox, so thanks for coming and choosing this talk. I'm going to speak a little bit about Spring Cloud and some of the discovery and configuration systems that we integrate with. Feel free if you have any questions, go ahead. We'll also have some time at the end. But a little bit about me. That's where I'm from, Salt Lake City, so a long way from here. My first time in Paris, so it's been a great time to see the city and enjoy France for a little bit. I work at Pivotal. Some of the things we do, I work on the Spring team. The estimable Josh Long is here. Raise your hand. He's going to give a talk about Spring Boot in the next hour, so go see that. And Spring Cloud. He'll talk a little bit more about some of these things that we're discussing. Who here is familiar with Spring Cloud? Okay, a few of you. Good. We do a release train. There's many different projects in Spring Cloud. The names of the release trains are Tube Stops in London. One of the other project members, Dave Sire, is from London. So our first release was called Angel. That happened last year. We just released Brixton RC2 a few days ago. Anyway, we plan on doing hopefully getting to our general availability release at the end of this month. If we may do another release candidate, we're not sure, but hopefully that'll come soon. We'll have a release Camden that will follow Spring Boot, so that will include Spring 4.3 and Spring Boot 1.4 sometime later this year. And then our next big release will be Dalston, and that will follow with Spring 5 and Spring Boot 2 sometime at the beginning of next year. And there will be various service releases in between. Anyway, just to get a little update on when we're doing releases, our current release took a really long time, and we hope to not have that problem again. So a little bit on microservices. So we're going to talk about these things in the context of microservices. Not everyone needs microservices, right? If you're a fairly small team, a modular monolith may be the way to go. So just keep that in mind as we talk about these things. But one of the things that you find when you're doing microservices is that you need some kind of service registration. I can go back for that if you want to take the picture. Go. I couldn't find a good picture of it, so I kind of made one of my own. So when you have all these instances of services up and running, they need to know how to find themselves. Instances come up, they come down, so they have this concept of a service registry. And it's a pretty simple concept, right? There's this entity that lives somewhere, and when an instance of a service comes up, it says, hey, registry, I'm here. The most basic information it passes is a host and a port, right? This is how other services can connect to me. Service B comes up and says, hey, I want to talk to service A. Can you tell me about service A? And the registry responds, here's a list of hosts and ports. And then service B can call directly to service A, right? It doesn't flow through the registry. Requests go directly to the other instances. So that's the service registry, I guess, pattern. Pretty simple, and we'll talk about 3 different implementations of this pattern a little later. So some of the ways in Spring Cloud that you can interact with the service registry, we have an annotation that you can place on your Spring Boot configuration. Who here is familiar with Spring Boot? Sweet. That was almost everybody. So awesome. So you just throw this annotation on your application, and it will, given a little configuration, register with service discovery and make that instance available to the rest of your system. To ask about a particular service, we have a DiscoveryClient interface, and one of the methods is simply called choose, and you give it the logical service ID that the other service registered with. You don't have to know the host and the port. You just say, hey, give me a user service or an account service, right? And it will hand you back a service instance, and this service instance has a few fields. The ones that are most interesting are host and port, right? Your client needs to know, is that host and port HTTP? Is it something else, right? At Netflix, a lot of their services are REST-based, and so it's simply HTTP, right? But they also register EV cache, their cache, so it could be, some other protocol that gets registered, not just web services. We also integrate with Spring's REST template. So when you create a URL that you pass to REST template, you don't put a host name and port in the URL, you put this logical service name, just like this, except you just interact with REST template as you normally would. And then we also integrate with Feign, project that started in Netflix, but most of the users come from Spring Cloud. Adrian Cole, the creator of Feign, now works on Spring Cloud. But it's a declarative REST client, so you create an interface and annotate the methods on it, and then you can distribute that to other clients in your company or something like that. And it's also integrated with DiscoveryClient, so you don't have to pass it a fully qualified URL again, just the service ID. Any questions about Discovery? We'll get into the details of some of the implementations here in a minute. So another important part of these distributed systems is configuration. Who's here has heard of 12-factor applications? A few of you, good. One of the tenets of a 12-factor application is that your configurations should live outside of your application. In fact, they recommend environment variables, which Spring Boot will happily use. But one thing that we've found is that you still have to manage where those environment variables come from, right? And it can be tricky to get that right. So Spring has an environment abstraction, and we hook it up to some external configuration system. We still think it follows the spirit of the 12-factor configuration recommendation. But so there's a configuration system, and when an application comes up, it says, "Hey, I need my configuration," and it may pass some parameters like the environment that you're in, dev, test, or prod, for example. We use Spring profiles for that. But, hey, configurations, I'm service A, I'm in dev, can you hand me my configuration for me? And same with any other service that comes up. Again, even simpler pattern than discovery, just hand me my configuration. That way it's not bundled with the deployment artifacts. So one of the things that we've added to Spring to accommodate this is a new phase in the Spring application lifecycle. So when Spring comes up, it follows a series of steps in loading the application context and creating the beans and wiring them together, right? It follows this life cycle, and when beans are destroyed, it will shut them down appropriately. But for the configuration to work, So given a service as it comes up, there's a new Bootstrap application context. What this does is it says, okay, I need to go get my configuration first before I start all these other beans, because they'll need information potentially that is stored in the configuration service. So it contacts the configuration service, it returns, populates a Spring environment property source, and then it continues with the regular application context. So along with this, there's a new configuration file. So if all you're familiar with Spring Boot, you can put configuration in application.properties or application.yaml, right? Well, there's a new one called bootstrap.properties or YAML. And really what you need to put in there is the Spring application name, right? Config server needs to know who's requesting, and then whatever information you need to connect to the configuration server. There are a number of ways, standard ways through Spring Boot and Spring to interact with the Spring environment. One is to use Spring Boot's @configuration properties. Anyone familiar with these? So this is you annotate an object and you get type safe configuration, right? The properties that go in the class match, a hierarchical property name, and it will populate it and can do conversions into ints or longs or booleans or lists and maps and all those things. So it's one of my favorite things about Spring Boot is this type safe configuration. You could also use Spring's @value and plug configuration into your classes that way, or access the environment object directly in auto-wire an environment object into your class and interact that way. But again, my favorite is the configuration properties because it's type safe, and there are a couple advantages to using that I'll show you in a little bit, because they can be reloaded if it uses a configuration properties a little easier than the others. So when we started, we saw a need for a configuration server, so we made one ourselves. So when we first released, a lot of Spring Cloud was based on the Netflix stack, but our configuration server wasn't. It was a greenfield project. It has an HTTP API, pretty simple API. There are only a few different options. And when we chatted with the guys from Netflix, it's actually similar to their config server, though theirs they haven't open sourced their config server. It's backed by a version control system such as Git. Git was what we built. A community member submitted Subversion. I guess there's probably a Java API to CVS or some other painful to use configuration services, but we do have a pull request for a database-backed config server as well. So it's really pluggable. But we liked Git. So config server is stateless. Whenever configuration is requested, it goes out to the Git server and pulls down the information for the request. So you can run as many as you need to handle your traffic. One of the interesting things that we created was this concept of a refresh scope. So you can add this annotation to your beans, and we'll create a proxy for them. And we added a new actuator method called refresh, that if that gets hit, these beans will refresh, and what happens is it will go back out to configuration server, get that new information from configuration server, and recreate those beans for you. Now, you don't need this if your configuration is in a NAT configuration properties bean, because those get automatically refreshed. So those will always be up to date, and you don't need refresh scope. But if you had something in @value, for example, you would need to use this. We also can send a new feature in Brixton to send plain text files. So we've had a couple of people use that for distributing message sources, for example. So your internationalization files can be served up by a configuration server. Let's see. We use standard Spring Boot configuration files, so you're all familiar with the properties or YAML and all the, you can put placeholders in them just like Spring Boot. So you don't have to learn anything new as far as that goes. We do have a client that will get auto-configured and connect, so that if you just put the host and port of the config server in, it will automatically connect and bring down your configuration for you. I mentioned this, the refresh. Well, you can also refresh via events. So this is based off of Spring Cloud Stream, which I don't know. Josh, do you talk about that, or do you have time to talk about that? It's a way to do message-driven microservices. So we plug this in, and we have this concept of a bus that you can send a message saying, hey, all of you user service, refresh. And they'll all get it and all refresh. One of the most requested features was, well, when my configuration changes, I want to automatically refresh my microservices. Well, Git doesn't have that natively, right? But some of these implementations of Git servers do. They have webhooks that you can configure. And so we have webhook support for these particular Git services. One of these things that I don't have a bullet for, one of the reasons we went with version control systems is that you get all the goodness of version control for your configuration, right? Auditing, versioning, you can roll back, you have branches, you have whatever service you're using, whatever security they have, you get all that with your configuration. So people ask, how should I set up my Git servers? What should I use, one for everything? It's like, well, you probably don't want your developers pushing directly to the production one. They could do it by mistake, right? Well, so you probably split that up and have different security for production versus the others. GitHub has branches that you can have different rights on too. So that's one of the reasons we went with a version control system like that, is because of all the benefits you get. At Netflix, they don't have it backed by Git. They use a database. So they had to build all the versioning and security into their API that fronts their database. So that's one of the difficult things about using a database. Another nice thing about this is we do have commercially supported and managed config server in Pivotal Cloud Foundry. Okay, demo time. I'm going to try and show you something about config server. We'll see if it works. My keyboard shortcut to go from mirrored to separate wasn't working, so let's see if I can get this going. Okay. So Josh is going to show you how to build these applications. I'm just going to kind of run them and show them to you. So here is a config server. Everyone can see that okay. It's really, really bare bones. The most interesting about this class is this annotation. So I'm going to go ahead and run this guy. Just a few seconds here. Can't see if I have. Okay. I have Wi-Fi or not. Hopefully we'll see something here. So if I go to so in the API, this is a little hard to see, but the first parameter is the name of the application, and the second one is the profile. So here you see this came from config server. It went out to this GitHub URL and loaded just these few properties. Okay, so I could say, well, you can see this came from a file called application.yaml. Application.yaml in config server means I'm available to every application that comes. So this is where you can put default properties that everyone would need. But if you wanted to override one, say for app foo, now you can see not only did I get the information that comes for everybody, but I have a specific one for me. Okay? So now things get a little tricky. So I'm going to run a client, and this one, there's nothing actually important in the in this class. Really, the important thing, if I show you the POM of the config client, is the starter that I used. So I Spring Cloud starter config. Gets me the config client, and it's automatically set up. So I'm going to go ahead and run my config client. Okay. Now if I go here, my client's just running on port 8080. Show you that the env actuator endpoint. Josh will show you this some more, but here you can see I have two property sources that came from configuration server. Okay, pretty simple. I showed you that information in the HTTP API, but this used the Java client to automatically go out to the configuration server and load this, along with command line arguments, system properties, environment variables, and the other parts of the Spring environment. So now the thing I'm going to try is, anyone heard of ngrok before? It's this cool little proxy application. So I'm going to run this, and what has happened is I've connected to a server that ngrok maintains, and they are going to proxy back to this laptop. That makes sense? So I just gave this laptop a publicly accessible internet address, is what just happened right there, forwarding to my config server, okay? And this is the, I can't see it all. So this is the URL for my laptop right here, but you guys could hit it if you really wanted to screw up my demo. So what I'm going to do is go to my configuration repo on GitHub. To the settings, webhooks. So I've done this before. So when you set up config server, and if you put, you get a new endpoint called /monitor, and that's what you should point your webhooks to. So if I come in here, now point this at my latest ngrok server. If you pay, you can get a name, so it'll never change, right? But for free, it changes quite often. So if I come in, now we're going to edit this file live. So remember the property foo, its value was bar. I'm going to change this to Devox France. We're going to commit this, And let me go back to IntelliJ. You'll see some text here that we're refreshing the context, and the keys that were refreshed was foo, and if I come back to the environment, you'll see that it now has the new value. Yay, it worked. So all that happened through the internet, through a locally running RabbitMQ. Config server put a message out on RabbitMQ running on my laptop, which then notified the other config client, here's a message, you need to refresh yourself. So it then went back out and got the new values. Okay? Wow, I need to move. Okay, so let's go back to the display. Hopefully I might not be able to do one of my demos if I don't get enough time. All right, so that was configuration. Now let's talk about service discovery. The one that we started with was Netflix Eureka. Okay, Eureka was built to be highly available. Netflix needed it to run at all costs. So they chose availability over consistency, right? If you're familiar with CAP theorem, they would prefer Eureka to serve stale data than not to serve data, okay? It was mature. It was one of the most, I mean, they run thousands of instances that connect to Eureka every day and go down and come up, and it's proven. So that was one of the reasons we went with it. So it has tight integration with Ribbon. Ribbon is their client-side load balancer. So rather than asking for a list of service of hosts and port, Ribbon will, given a load balancing algorithm, give you one, right? Like round robin or random or something like that. And again, we have commercial support for Eureka and Cloud Foundry. Some of the cons of Eureka, it's all in Java. The client is written in Java, and it's pretty heavyweight, and you really have to use the client or understand the protocol really, really well. So if you have other languages in your company or project, it can be a little difficult, and you need to use a sidecar to be able to register those applications with Eureka. Initially, it was built for AWS, so there's some things that are specific to AWS, like regions and zones and that kind of thing, and so sometimes it's hard to understand exactly what's going on when you're not running in AWS, for example. There are some interesting registration and cache refresh timeouts. So it can take between 90 seconds and a minute before you see a new instance show up. So if I registered service A, it might take service B 90 seconds before it would see that new instance. You can tweak that with properties, but by default, those can add up to 90 seconds to 2 minutes. Sorry. But we've had fabulous success with Eureka. So another system is Consul by HashiCorp. Who's heard of Consul before? Awesome, that's a lot of people. For those of you who have never heard of Consul before, have you heard of Vagrant? Okay, made by the same guys. Okay, Mitchell Hashimoto and his company, HashiCorp. It's got an interesting topology that uses a peer-to-peer gossip system to communicate. So you run a cluster of servers and then agents that connect each client with, it's called an agent that connects to the cluster of servers. It's written in Go, not that that matters, but if you like that thing. An interesting thing, this console has first-class support for service discovery. So that is a concept in console. Has APIs dedicated to service discovery. It also has a key value store, which we use for configuration. Console fits really well if you have a polyglot environment, right? It doesn't matter what language you're using, because everything, you can get all the information out of console via an HTTP API or DNS, right? Like some legacy applications, that's the only, you can configure them with a host name or something like that. Console also runs a DNS server. So if you have legacy apps that need to connect via DNS, it's pretty slick. It has security built into it with access control lists, which is really, really nice feature. And health checks. So as part of service discovery, you can configure all sorts of health checks for your services, whether that's a simple HTTP call, anything you can run in a shell, you can use to check that your service is up. Has data centers as a top-level concept, so you can run console in multiple data centers and they will all communicate. By default, you'll get answers for your local data center, but you can ask to go remotely. Console has some Vault integration, which I hope to demo here in a few minutes. Vault manages keys and secrets. Supports this. It doesn't support files per se, but it supports the contents as blobs, can be properties or YAML, just like normal Spring Boot. I think I mentioned that before. It uses a gossip system. Has a neat little UI that you can use to inspect all of this. I'll hope to show you that in a second too. So some of the cons of console, it's new, right? It's got a growing community, but it's fairly young. So compared to some of these other systems, it's the baby, it's the new kid on the block. Some people might see this as a con, but usually the way you set it up is you have an agent running on each node, right, that you communicate with. So there's a cluster of servers and then your local agent. I kind of like that because then you only have to configure your service to look at localhost 8500 and it will always work, whether you're in dev or production. To get to console is always localhost 8500 if you're running an agent on every host. You can do things a little differently, but it just works if the agent is localhost. All right, let's see if I can show a little bit of console. Back to my displays. So let's see. Close these guys. Stop these guys. So I already have a few things running that I set up before. Hopefully they're still all working. So in this terminal is running console, and this one is running Vault. Okay, the simple application they run on. Since they're written in Go, they can run on all sorts of platforms. And I have a very, very simple application that I use this enable discovery client, so when it runs, it will register with, in this particular case, console. And the reason I know it's using console is because I am using this starter, right? So I said use console for discovery and also use console for configuration. So I'm going to run my application A. Something failed. see how these things go. So I think what has happened is that when my laptop went to sleep. So Vault is an interesting thing, is it requires you to unseal it using 3 different keys. It's really quite secure, but when you're running demos, it's a little annoying. Okay, let's try this again. Hopefully my unfortunately, what I think has happened is that these tokens that I created the other day have expired. So you get to see me do some things that I was hoping to avoid. So I'm creating some tokens in Vault. And I'll show you why those are important here in a minute. Okay. Awesome. App A. Make sure I got the right. Of course, this is going to go this way. Okay. Well, I was going to show you a cool demo showing Vault's ACLs in action, but it looks like I won't be able to. Oh, there it did work. Shows what I know. So you can see that not only did we go to consul for some information, we went to Vault and got a secret specific to our application. Okay, well, if that's the case, I'm just going to keep going. So here's app B. It's a different name, different token. See, it has configuration for app B, and it's app B's secret. Well, now what if I'm going to, one of the problems with this is we base all this just off of the name. Well, name's arbitrary. I can put whatever I want in here. So I'm going to masquerade, sorry if you can't see that really well, I'm going to masquerade app B, and I'm going to put app A's name in. So without security, I would just get app A's configuration and just see it. So I'm going to go ahead and run this. And the reason that exception scared me is because that's part of my demo. It's like you see a forbidden here that app B using app B's token got forbidden in, let's see which port this is, 992, is on. So if all this worked, you'll see that it didn't get any information from Vault's app A token. Okay, so it did work. Good. So, and this is another interesting thing. We're using 2 separate external configuration systems here, consul and Vault. Now I was going to show you the neat, nice UI here. That here I'm looking in the key value store for configuration, but you'll also see there's Vault here. But if you go find any information in here, it's all encrypted using those keys that I showed you earlier. And then you can also see the different services that have been registered. So it's a really nice UI. But I need to come back here if I'm going to to finish. Oh, come on. Finish my presentation. Oh. Sorry about that noise. I haven't been able to make it go away. So Zookeeper is another system that people use for configuration and service discovery. It's the oldest one of these, this bunch. In fact, Netflix uses Zookeeper as part of their stack, just not for service discovery. It's a consistent store, and using that consistency, you can do all sorts of different things. One of them being service discovery, one of them being configuration. There's another project as part of Spring Cloud called Cluster that can use Zookeeper to do leader election or distributed locking, for example. But we're just going to talk about using it for configuration and discovery. So it started life a long time ago as part of the Hadoop ecosystem. It's pretty mature, used by a lot of companies. A lot of distributed open source projects from LinkedIn or wherever, one of their core requirements a lot of times is Zookeeper. So if you have Zookeeper as part of your infrastructure, this might make sense to use for registration because you already have it, right? Why introduce yet another thing? And with Spring Cloud's abstractions, you know, it doesn't change your application much at all. In fact, you could set it up with profiles. We've done this. This is how we do end-to-end tests. We have one application. We test it with Eureka. We switch parameters. We test the same application with consul, and we test it with Zookeeper. So the same application, no changes. It uses ephemeral nodes and persistent connections as its heartbeat, as its lifeline to service discovery, where consul uses health checks, Eureka sends heartbeats, Zookeeper uses these persistent connections. This uses the Curator is a library that started at Netflix that has a service discovery recipe. That's what we use. Donated by a Polish company with one of its architects that now works for us on Spring Cloud. Nice guy if you ever meet him. Some of the cons, I have not run Zookeeper in production, so these are things I have heard from people and have read about. Okay, so a little disclaimer there. There can be scale issues. Now it's gotten better as it's gone along, but there can be issues with scaling Zookeeper past a certain point. Now, if you're well under that point and have the overhead, great. It has been said that it is difficult to maintain operationally. Again, I think that has gotten better recently, but it still can be a pain. You might need a management process like Exhibitor to keep things running, or say if you're running in AWS and a Zookeeper node goes down and you replace it with a new one, the cluster configuration is static, but Exhibitor allows you to update that cluster configuration. That same pro of a persistent connection could also be a con, right? Because you have to have a connection from every instance that's using Zookeeper for configuration and for service discovery, actually for service discovery, not for configuration, has to have a persistent connection to Zookeeper. So if that number gets sufficiently high, you could have issues as well. I'm getting really, really close to the end. So I just wanted to show some other systems that are available for service discovery and or configuration. You know, these guys have been around forever. They work, right? And for your application, that may be the best thing. In fact, Josh Long wrote this one. No. Dave, I'll show you what Dave did just the other day with it. A system like Cloud Foundry, it knows about all the instances that have been registered, right? Do you need another system? Well, maybe not. So we have this read-only interface for Cloud Foundry. I've played with etcd and got it to work with Spring Cloud. Airbnb has their own stack. If you really want to be blown away by one that's really, really different, go watch this video on Hyperbond from Uber. Pretty slick. I'm blinking over time here, so if you want to grab me afterwards and ask me some questions, Josh is speaking about the beautiful microservice in I'm going to mispronounce this, Malloy? Mayo. See, I told you it's going to come out like Portuguese. This is the repo for the code that I showed. My slides will end up here. That's my Twitter handle. Like I said, I'll come down and you can ask me questions, but we'll leave room for the next presenter to come up. So I appreciate the time. Hope it was informative.